Yeah, you want to go to YouTube and search for UUASC and see if you see the Hangout on there. Test the feed. Hey, John, how's it going? Hi. No, these guys can be busy. What happened? Uh-oh, do I need to read it now? Okay. Okay.
So, are you the one that hired Omar?
Oh, we love him too.
Probably almost a year ago. When I met him, I was like,
if you search for UUASC, you should say UUASC October.
a lot of companies are just kind of drawing a line in the sand and saying, oh, they come to have this stuff. And hey, no offense is potential. I'm like, this guy is so smart. He understands things at a deep level. And like, I kept submitting him to jobs and they kept saying, oh, he doesn't have to do anything. He doesn't have this, he doesn't have that.
Good.
Yeah, he's like a genuinely like a good person and like bright and educated.
Oh, maybe
he's always like he's good enough and he's like you're much better than me. He's so excited about it. Exactly. You're gonna get exposed to so much stuff that it's like he needed this stuff. You know, he really did. And I was just like, someone, he's gonna make someone really happy with me. One day, like I don't know why everybody wants him, but I guess they're waiting for you to find him. So you get it. I'm so excited.
Okay.
Yeah. I know.
We're live. Here, this is what it looks like. It's on Hangout on air right now. And I'll pull it down.
People can open their eyes.
I mean, stand there, that's good. So, Mike's right there. Right. Do an intro, I guess, in a minute. You got a pretty decent crowd already. It's 7:12, maybe with a couple more. By the way, did you already put your slides up on your site? Okay, because you done it?
I hear that all the time. I'm like, we need another whoever.
Have you met Ilya? He got your. Okay. Yeah, he met you at Max CDS. Over there, man.
Did they get
competitive.
Jordan, people keep unplugging stuff.
Huh?
People keep unplugging stuff and now the fan. It's just, I think it's unplugged.
Okay.
I know, that's what I'm saying.
Here.
Okay.
Well, here, all right.
So it was nice meeting you.
Here,
You'll
we
be
can
working
plug
remotely
the fan
tomorrow.
in.
I think I'll be in the morning.
Yeah, works.
Cool.
Right,
No
and,
worries.
Yeah, he's still be there too, I think. Yeah. Okay. All right, I'll see ya.
Yeah,
Yes, yeah, we can pull this chair out. No, here, yeah. Right there. Work.
Yeah, I run my Facebook project. Pops up and I'm like, should I? No, thanks for.
Actually, you charge your phone here? Wait a second. Yeah, okay, why don't you put your phone out, Ralph? Yeah, keep going. Just keep going.
Wow.
Just want to keep the fan somewhat away from the mic. Anywhere back there should be fine. Okay. Hey, Justin, how goes it? Just in time. All right, so I'll do the intro. I'll bring you up and then Adrian will bring it up. Okay, hey everybody, welcome to the October 2014 UUASC Unix User Association of Southern California LA chapter meeting. Thanks everybody for coming. For meet new people, UUASC, the main thing to be a member of UUASC is we have a mailing list at uuasc.org. Feel free to join our mailing list. There's good discussion there and talk about Unix, Linux, other kind of stuff. We have two chapters, an LA chapter and an OC chapter. The LA chapter meets somewhere on the west side the first Thursday of the month. Of course, our speaker Adrian couldn't make it on the last Thursday, so we shifted it out to today. So thanks for coming out on this date. And I thought I heard somebody saying maybe they have a regular meetup on second Wednesday or whatever, but we'll be back to our regular Thursday thing. Because John, our speaker for next month, John, is here. He'll be talking about advancements in the Linux networking kernel the first Thursday of the month. Maybe here, maybe somewhere else on the website. Join our mailing list, and that's one good way to keep abreast of when the next meetups are happening. We also have two other mailings. Another one is called UUASC-Now. That's just for announcements, like we're having another meetup, or Obama's going to be in town tomorrow, so don't go to Santa Monica. that's a joke. And the third list is UUAC-Jobs, and that's a moderated list for posting Unix or Linux-related jobs in Southern California. Or if you're available for work, you can post a link to your resume or a text-based version of your greatest hits. The interesting thing about the UUAC jobs list, it is moderated, but you don't need to be a member to post there. So if somebody's hitting you up for some particular job, say, hey, I'm not interested, but hey, you can throw your opportunity over to the UUAC-jobs list. And then the moderator will look at it, and if it looks legit, he'll pass it on. I think those are the major pieces. I don't know if anybody else has announcements for other meetups. No? Okay.
I do.
Okay, there you go.
LA DevOps.
Here's Lars Lettman.
LA DevOps is going to be off by 1 hour this month. We're doing it last Tuesday month to last Monday, and we're doing it at DreamWorks in Glendale again. I am giving my burnout talk in Seattle.
Oh my God.
Month. So
Lars' burnout talk is so freaking awesome.
I am giving it in LA as a practice run, since I haven't done it since January or February. So I'm doing it there on the last Tuesday this month. And John Haddad from DataStax will be talking about some Cassandra operational stuff.
Ooh, Cassandra.
Yeah, right. So up your salary by 30K just by knowing the word.
Yeah, but you got to spell it right.
There you
it's
go.
2 S's, isn't it?
That will be covered.
Okay.
So yeah, so we don't have it on the site yet, but it will be on there.
Okay, cool, good. So you heard it here first. And also, Lars did his burnout talk at the DevOps Day LA at Scale, Southern California Linux Expo, last year. And I did want to mention that the call for papers has been open for Scale. It's gonna happen in February of next year at LAX Hilton.
Deadline is December 10th.
Huh? Deadline is December 10th.
For the papers.
So get writing them proposals. I guess one other, it's going to be a lot of fun. So definitely, if you're not, everybody here knows about Scale? Yeah, nobody. Okay. He doesn't know about Scale or scaling, but hey, it's still fun to work with. All right, so I'd like to thank our host for this wonderful facility, Carolyn at Q. Carolyn, why don't you come and tell us what's happening here?
Awesome. So thanks for saving. Thanks for saving me a bullet point on my list here about Scale. So awesome. Also, wanted to talk about SoCal Code Camp, November 15th to 16th at USC. So I don't really know what that is, but check it out.
Yeah, it's actually, that's been going on for a few years. It's a lot of application development seminars, and there's a little too much .NET there, so we need more open source people to bum rush that shit.
So
Right.
I was instructed to mention it.
That, I'm just saying that for Matthias, our
Yeah,
scale
that's who
and
asked me to.
hype man. Yes.
So, in case anyone's not familiar with Q, we are a recruiting firm here in LA focused on the tech industry and just here in LA. So we're very involved with our community, which is why we love to host meetups, sponsor meetups all over town. I also have my own meetup, UUASC-LA. We were supposed to have it last night, but it kind of got canceled. Very ironic. They were having production issues. So rescheduled for October 28th. So hopefully everyone can make it. Meetup.com/UUASC-LA. So be sure to check that out. It's breaking up with your data center and moving to AWS. They'll also be talking about Ansible, which is both of those topics right now are very popular. One of the services that we do provide for no charge for everybody knows this. Just like kind of a market read, like call us up anytime, ask us like what are hot skills, what are people looking for? Like we're always happy to tell you what we're seeing in the market. So right now AWS, Chef Ansible, that kind of stuff, super hot.
What? No salt?
A little bit. Yeah, I learned that. So in Puppet it's called a module, in Chef it's called a recipe. In Salt it's called a pillar, and in Ansible it's called a playbook.
Woohoo!
Yay!
You're hired.
I learned things. So yeah,
Just added another 20K to your salary.
Exactly. So we do try to do things a little differently than your average recruiting firm. Try to kind of know what we're talking about, and really do right by you guys. No pressure. We just want to help people, find good jobs. So that's what we're all about. So
Cool.
if you are looking, if anyone you know is looking, or if you're hiring, or anyone you know is hiring, we're always happy to help out with those sorts of things. And again, like Kel knows, resume help, always happy to provide it. We don't charge for any of this stuff. So I'm in the back if anyone needs me. A couple other people are back there as well, and feel free to come up to me afterwards and ask any questions you have. I think that's about it. We do have current jobs right now: hot skills, AWS, Hadoop, Ansible, Chef, Puppet, release engineering, and scripting. So any of those things, if you're looking to get back in the job market, definitely focus on those things. What? Awesome. Well, thanks, Adrian, for speaking. I'll let Jordan introduce you, and if anyone needs me, back.
Hey, thank you very much, Carolyn. And yeah, by the way, I happen to be working at Edgecast, Verizon Digital Media Services, and of course we're always looking for people. Big Linux shop, a lot of interesting work to do there. So if you're interested, definitely chat with me afterwards. And by the way, after the meeting, we will retreat over to Islands Cafe, grab a table and some drinks and some food. So you're welcome to join us for some post-meetup chit-chat. With all that said, now to our main event, Adrian Otto, here to talk about containers for multi-cloud applications. Yes, there's an app for that.
Yeah, I'm not going to speak on camera because I don't like
No worries. It's really to get the slides.
So you all came to hear about containers. Tell you who I am and why this container talk has an OpenStack over it. I work at Rackspace. I am a principal architect there. I've been doing that for 7 years. I work on OpenStack, and I'm the chair of the OpenStack containers team. I also serve as the project technical lead for the project SOLE, which is an automation system that allows you to do CI/CD with OpenStack files. And I'm the co-chair of the Oasis Camp Technical Committee. So I work in cloud standards and the actual implementations of those in real life. So it's a multi-cloud application. What I'm talking about is the ability to deploy your application to the cloud using an automated process, and then deciding you want to deploy that same application to another cloud. What I'm not talking about is I have a single application that's running concurrently to multiple clouds. The reason why I'm making this point of clarification is because if you want to do this, your application and its data stores need to be designed. Regular applications will not work in this system architecture. So if you're going to be writing one of these straddle clouds, you're going to need to be writing it using one of these libraries in order to interact with the infrastructure layer if you want your app to interact with the infrastructure. So if you're using Ruby, look at Fog. If you're using Python, look at libcloud. If you're using Java, look at jclouds. And if you're using Go, look at GopherCloud. There's a bunch more as well. Now, this talk is really about if you're not writing a new application for the cloud and designing it for doing this crazy cloud straddling, running concurrently in multiple places and automatically healing when it's wrong, then what you're really trying to do is take some existing application, forklift it so it can run in a cloud environment, and there is new technology and old technology that you can use together in order to do some of this. So when I say cloud application, what I mean is something that is designed for the cloud and written for the cloud and implemented for the cloud. When I say application running on the cloud, what I'm talking about is this, where you've got something that is agnostic of what's running underneath it. It was not designed with the cloud in mind, but you would like to have some way to do this, choose where I send this application, and not marry myself necessarily with one kind of cloud. So if you don't like this talk, you can just look at this slide and you've got the whole thing. You can go now. This is the entire story. You containerize your applications. You use Docker files in order to create container images. I'll talk about what these are. You store the images in a repository, just like a source code repository, except it's called an image repo. You run Docker on each of your cloud servers so that you can consume your cloud images out of your repository. You back up your storage in the target cloud where you're planning on doing your deploy. And then when it's time to run your application, you start the container, load and mount the storage, and you're off on the races. All of you are thinking, yeah, that sounds great, but about the 25 different things that are very important details. First of all, I don't know what Docker is yet. I don't know what a Docker file is yet. When you're talking about image repository, I have no idea what that is. I have a big application that runs on a lot of servers, or I have a need to run a mix of servers. What's common is data servers and app servers, and they're in some kind of a, amalgamation of configuration. Or my app has a ton of data. And these are all the kind of problems that people have when they're trying to conceptualize using containerization or using Docker as a tool in order to do a multi-cloud app facility. So I'm going to talk each one of these questions. There are a lot more, but these are the ones that come up once. So I'm going to hit each and every one of these. Containers are not a silver bullet. You already have all the tools you need in order to do multi-cloud. Containers just make it a little bit easier for you to do that. All of the same hard problems are still hard problems. They're just not as hard as they were before. So Docker. How many of you seen my Docker 101 or have gone through some kind of a introduction to Docker? Okay, so I have like 5, 6 maybe in the audience. I have like a pretty good solid understanding of Docker and how it works. How many using Docker running production apps today? Okay, one. Brave soul. Okay. Me too. You should come to on October 15th. There is a meetup for the Docker Los Angeles group that I'll be hosting in El Segundo that is about running Docker in production.
We use it for our build slaves. So
oh, okay. Well,
not quite production, but
anyway, there's lots of Docker limitations that you learn about when you start using the software, and that meetup is all about all the quirks and how to get around all the quirks. Okay, so first thing you need to understand when you think about Docker, is Docker the thing that runs? Is Docker the thing that you store? Is Docker the controls around it? Is Docker the control surface for an application? Is it, what is it? What I want you to take away is it's an amalgam of 3 concepts. The concept of C groups. These are the way that you group processes within the Linux kernel in order to put a policy over those running processes. So how much CPU can a given process consume? What priority the grouping of processes has among other processes running on the system? How much I/O are they allowed to do? How much network IO types are they allowed to consume. There's all kinds of limits that are available in the kernel. C groups have been around 6 or 7 years now. They're very mature. They're not widely used because they're not very easy to set up. Namespaces are different from C groups. Namespaces are a way to limit your perspective. You are a running process on a Linux system. It can limit your perspective to various resources on the system. So the most obvious one is I have a PID namespace. PID namespace means I've only seen processes that I have started. So normally when I log into my Linux box and I run PS, I see, maybe 20 or 30 different processes that are running in support of running that system. When I'm in a PID namespace and I've just started it up, I might see 2 or 3 things in -A. Even when I do a PS -A. Okay, now you can namespace all sorts of things in the kernel. IPCs, you can namespace networks, you can namespace just about everything, including the newest one, which Docker doesn't yet support, called user namespaces. When you are UID 0 on the system, you are granted a certain capability in the kernel called capsysadmin. Capsysadmin allows you to do certain operations like file systems, start and stop processes, signal things, so on and so forth. So if you have the capability capsysadmin, meaning you are running context with the Linux shell, you can do anything you want on the system. Now, what if you're in a PID namespace? Now you can maybe only access the processes that you started. And if you're in a which namespace? User namespace, thank you. User namespaces map your running UID within your C group to an external UID external. So you have the illusion that you're running as UID 0 within the container. You're given certain capabilities up to and including capsysadmin inside your container, but you're not actually running the process as UID 0 on the system. You just have the illusion that you're running a UID 0 process within your user namespace. So PID namespaces and user namespaces together are a nice little security tool to do reduced attack surface for escaping from if something goes wrong in your app. It's a good idea to containerize your app, even if you're not in the business of carving up your machine into something that's going to run a million different instances of something or different somethings. It's still a good idea to try to reduce attack surface of your app, and that's one way you can do it. Mandatory access control is another one. That's not technically part of the container. Okay, so did I answer the what is Docker question? Or I'll pause for questions if what is Docker isn't clear. Because it's like a 45-minute talk that I've compressed in like 30 minutes. Okay. So what is a Docker file? Everyone here has seen a make file. A Docker file is just a make file, except the inputs, instead of being C files, the inputs are these script commands, and the output, instead of being a binary, is a container image. So a Docker file is just a way to produce a container image. Container image is a thing that you use to produce a container. So it's the namespace plus the C group plus the image, or what gave you your container. So a container is an entity that has a life cycle. It can be in different states. So it can be running. It can be paused. It can be stopped. It can be destroyed. So depending on what you're trying to do, you might intentionally say start a container, kill the processes in it, but leave the container around so that you can later restart those same processes again, and they're all in the same environment that they were in. It's a good way of, like, if you have something that's really memory intensive and you only want to run it sometimes, but not all the time, you want it to start up in exactly the same way that it was when you left it, that's a great use for a container that's been stopped. So this is a simple Docker file. This says I'm extending from the base image called CentOS. I put a label on it. Maintainer is an optional thing. You don't need to put in. I'm going to run a command. I'm going to go install Apache here. I'm going to expose the port 80. So in my network namespace, I kind of glossed over this earlier. My network namespace by default is closed, so it doesn't allow any communication out of the container. This is how you pinhole certain ports so that you can access those ports from the host or from whatever IPs you bound the containers to. So this says just allow access to port 80 within the container from outside. and then I've added a file from the directory where I've run the build command with this Docker file. So if I were running this on the command line would be docker build dot. I run docker build dot in a directory that has a Docker file in it. It will run all the commands, and any files that I reference are looking for the directory. So in order for this to succeed, this build to succeed, I need two things in my directory. I need the Docker file, and I need start.sh. So when I start this container, by default, what the cmd command says, by default, I'm going to run start.sh. But at runtime, when I start my container, I could override that to something different and want to run something else instead. Okay, third question I always get is, what is an image repository? This image repository is just a place where your Docker images are kept for you. Think of it like a code repo, like GitHub would be an example of a hosted code repo. Docker Inc. provides a thing called hub.docker.com, which is a partly free and partly subscription service where you can place your Docker images. And so because it's a hosted service, you can access it from multiple different clouds. So if you get into the business of creating images for your applications, you can put them in the code repository and be able to access them from different places. Works like Git. So all the same semantics work. So in Git, when you want to make a local copy of the remote source code, you say git pull, and you get a local copy. Same thing with Docker. When you say Docker pull, it makes a copy of that container image and places it locally so that you can act upon it there. You can also you can modify them, save them, and then put them back up using a commit and a push. So it's all the same. So if you've ever used Git, the semantics with the Docker commands and interacting with the repo is all the same. All right. So the other question is, well, I have a whole lot of servers. It doesn't make a lot of sense for me to start creating containers on hundreds of different machines. I'm going to keep track of what's running where I should start the next one. I need to create some kind of database to keep track of all these things and decide where to launch them, where to terminate them when one goes haywire and needs to be restarted, so things to take care of that. You wouldn't use Docker to keep track of all that stuff. It's not yet. It's not sophisticated enough to deal with that, what we refer to as the scheduling problem. When we say scheduling, we're talking about resource scheduling, not time scheduling. There are a lot of systems out there that already do this. Nova is one, which is in OpenStack. It currently tracks virtual machines. We've added a new project called Magnum, that does the same thing that Nova does with containers. There's a project that Google kicked off called Kubernetes, which is in the business of kind of extracting things all the way up to services. And the outputs from Kubernetes are Docker containers that get launched on a set of basically worker hosts. So you have a slave that runs on every one of the execution nodes. That thing ET phones home to the central controller system. So it's like a master and minions. So the master dispatches jobs. It's an awful lot like an MPI system. All right, treat application servers like cattle. I'll get to this again in a minute. But in order to do lots of servers with using containers, you just need to have a predefined method by which you create these things using automation. You never log into a box. Ever. Right? You never log into a box. Using immutable infrastructure behavior, you have an automatic way to start things. You don't care about if they go wrong. You just kill them off and start one.
What if you need to patch your bash instance for that legacy CGI application you're running?
Great question. What if I needed to? I will answer that. So if I need to patch bash because there's a little exploit in it, it's very nasty.
That somebody just found.
I would go back to my Docker file and I would add yum update bash to my Docker file. And I would execute my Docker build command to create a new container image that has the updated bash. And once I have that, then I would run my application from that new container image. That's it. In fact, my new container image can actually be a descendant of the current one if I want. So let's say I saved this container image as Adrian's cool stuff. I can say from Adrian's cool stuff, yum update bash, save that Docker file, run a Docker build against it. Now I'll get a descendant of that that has the patched bash in it. Now I have a new container image that is patched. I do a redeploy on that, get that into production, kill off all the old ones. That's how you do it.
Cool.
Okay, now talking about all of the cattle herding software is kind of beyond the scope of this talk, but you're going to need to pick one of these systems in order to do that. All of them are relatively new. Nova is less new. Functionality that you get running containers within Nova is relatively limited. Nova today has a pluggable interface for what we call virt drivers, virtualization drivers. So the most common virt driver, the default one, is KVM. So when you say create instance in Nova on your cloud, what you get back is a virtual machine that's created using KVM. You could install the Zen hypervisor virt driver instead and get Zen VMs back. You can install the LXC driver and get LXC containers back. Minus a lot of features that VMware can do. You can put the Nova Docker driver in, and if you do that, you get Docker containers back when you create instances. The drawback of using Nova with virt drivers for creating containers is that you can't specify various flags at runtime for doing cool things that I'm going to talk about in a minute, like blind mounts, your port mappings, anything like that. So if you want to do anything exotic with containers and you're really, really cool, you're not necessarily going to have access to all that, but you'll at least have a basis to be able to start and stop stuff. Yeah, Adrian, but my app needs a database server. And the database server has to be up and running, and I need to know what username and password are for that database and what IP it's running on before I can start my app, because my app has to be configured on the fly in order to come up. How do I solve that? Okay, well, first of all, that's not one app, that's two apps. One app just happens to depend on the other. So you've got a data app, and then you've got the actual app that uses the data app. So you first start data app. So here I've got a Docker run command where I'm using a volume mount on just a sec. It's running on port 3306. This is my SQL server, and I'm using a Docker container named MySQL with the label latest. So it's going to look in my local list of Docker images that I've got from my Docker repository by doing Docker pull. I've got a Docker pull MySQL, and I've got a container there. By default, it will be labeled as latest. I can create new ones and label them as latest if I want, in order to change what actually runs. I say Docker run -v means take the storage that's on my Linux host and expose it directly to the container. So that when I use my storage in my container at this specified mount point /my app, what I'm actually doing is modifying files that are in /data /my app on the host. So it's a way of short-circuiting so that you can have access to the file system on the host for a given mount point, or a given path within a mount point. So the reason why you want to do this is because when you put your storage, when you're storing things within a container on the container's file system, that stuff is all getting stored using the storage driver that is backending Docker. There are two popular storage engines. One is based on AUFS, which is based on a merge file system design. The other is the DevMapper. So any of you who've used LVM, the libraries that implement LVM for block storage underneath your file systems are exactly the same drivers that implement the DevMapper backend to Docker. So to put a simpler way, when you store things in your Docker file system, if you're using the DevMapper storage backend, which is default on Fedora, CentOS, Red Hat, Linux, all Red Hat variants, then what is actually getting persisted to disk is going through the same code that your LVM storage goes through. So you get the ability to do things like creating copy on write snapshots, quick cloning, creating descendants, so on and so forth. So the DevMapper backend is a great, very reliable way to have this nested container image capability, which I didn't talk too much about, but that's one of the cool things about that. All right, so never run your database storage on your container file system. I'll repeat that. Never run your data storage in the container file system because your performance will be worse. Your storage is limited. By default, that's to 10 gigabytes, which is a very annoying size. You can change the size of the file system that gets created in the DevMapper, but the tools for managing that are relatively low level, so you need to know exactly what you're doing in order to actually manage it and grow those things. Not a lot of easy to use tools for managing that stuff. There's not any good reason to be creating a commit chain of block sequences for things that are changing all the time, all day long. It just doesn't make any sense because you're never going to roll back any of those prior checkpoints. So it doesn't make sense to do a tracked commit log of every single write to your file system. It'd be crazy. You never implement a file system that way if you're putting a database on top. So don't do that. Instead, run whatever file system you do like and blind mount it up to the container so that you can use the raw storage. So use all the same techniques you use today. You get your cool SAN gear and put 1,000 hard drives in parallel and do all the same cool stuff that you do to make storage fast, reliable, cheap, whatever you do, and you just connect that up to your containers and other. In order to get your database to come up before your app, you're just going to use orchestration software to do that. So if you're running an OpenStack cloud, you can use Heat for that. I'll give you an example of how to do that. You just make the output of one resource and input to another and create one as it depends on. It's very easy. This is how you do it. In the resources definition, here I have a server, which is saying, give me a VM, and it's called server 1. When I create that, it depends on database server right here. In order to get database server, that's the type OS Trove. This is the hosted database service within OpenStack Clouds. And it has its own properties, which I haven't listed because it's going to be on the scope here, but you get the idea. It's going to create this one before it creates this one. They're going to come up later once I get that. Yeah, you're going to have a lot of data. Remember I told you never put the data in the container in our file system? Well, if you never do that, then you have a lot of data. The solutions are all the same that you have today. Container doesn't make that any easier, doesn't make that any harder. The story is still replicate your data where you expect to use it. So if you actually want to do a multi-cloud app and you have a ton of data, you still have the initial replication problem to solve. But if you're keeping a reasonably up-to-date replica at multiple locations, say in your private cloud and in your target public cloud, and you want to do a switch from one to another, you can do that. Once you get the data laid out the way you want it in the target environment, then you would use a blind mount technique in order to get your container to access that data. All right, so here's something that I guarantee nobody in the room knows a whole lot about, libswarm. So libswarm was announced by Docker Inc. in earlier this year at the June or July at DockerCon. It is a additional daemon that you can run alongside Docker. So Docker has two things. Docker has a daemon that runs called Docker D, and it has a CLI command called Docker that talks to the daemon. And the daemon is the thing that actually speaks through to the container libraries in order to actually create the namespaces and C groups and all that stuff for you. So what swarmd is it's a way that you can have an alternate API endpoint for the CLI. So that when you ask for things in the CLI, instead of them going to the Docker daemon, they go to this other thing, which effectively acts as a proxy to other things running behind it. And the cool thing about libswarm is that the other things running behind it are distributed systems. So it has a pluggable backend. So one of the pluggable backends is for the Rackspace Cloud. There's another one for AWS. There's another one for GCP. So those distributed systems that are on the back are clouds in their own right. So when you say create a container using the Rackspace backend to libswarm, it creates you a cloud instance. So you get a virtual machine running in the cloud, which then can have a container The next one you say the next Docker run command you run gives you another container on the same host, and so on and so forth until that one's full. And then when you get state, it'll hold 10, right? So once you got to the 11th one, it's going to create you another one, and it's going to start filling that one out. But you're not dealing with those semantics within the Docker CLI. That's all happening behind the scenes. Additionally, what you can do is you can run a multi-cloud view concurrently. So remember at the very beginning I said don't straddle clouds unless you design your applications to straddle clouds. Well, if you do decide that you want to straddle clouds, and you've written an application that's designed to do that, and the data system is designed to handle that, then you can actually specify in your CLI command to give you, so when you do a Docker PS, the output of Docker PS is a list of all the links. You can say Docker -H path to my LibSwarm endpoint, location of my LibSwarm endpoint, -H path to my other LibSwarm endpoint, PS. And what I will get is a combined view of the running instances on both of those. So to the extent that I can continue to put more and more things on the CLI, of course there's a limit to how much of this I can actually stuff in, because it's the maximum length of the command, but I can put an arbitrary number of these things in order to get a combined view of all the containers that are running across an array of hosts that are running potentially on different infrastructure. So if I say, talk to my LibSwarm endpoint and talk to the Rackspace backend and get my full list, assuming it started 10 servers for me, each one running 10 containers, I'll see 100 containers come back by specifying a single endpoint. And if I did the same thing on GCE, I've got the 100 containers running on Rackspace, I've got the 100 containers running in Google, and I'm going to see the combined list of 200 containers running in Docker PS. That's how this works. All of this will change, which is why I'm not going to demo this today. But I will promise you this. This capability will be available to you and will be more accessible in LibSwarm. But if you really want to do this now, you can. It's just in the LibSwarm project. It will be somewhere else soon. For disclosure reasons, we can't say exactly where it will be, but all this capabilities will be more accessible to you and more easier to get at.
Can you tell us when you get back from Paris?
Yes, you'll know by the time. Well, yes, you'll know by the time I'm talking.
But you heard it here first.
So let's say I am doing this view where I've got my multiple swarmd endpoints. I'm running one swarmd instance, and it's got these backends loaded into it. And I want to get, say, I want to deploy my container onto, I know I want to put it on Rackspace Cloud for a good reason. You can specify that endpoint at the time you run the Docker run command, and so it will create it on that target point. So if you know you want to get your container up and running here in Cloud 1, you can do that. If you know you want to put it in Cloud 2, you can do that. But in my opinion, this is still pretty low level. If you're running a scheduler like a Nova on top or a Kubernetes on top or a Meetup on top, it's going to handle where things actually get placed. This swarmd gives you the ability to indicate where you want to go. Let's talk about the cattle and pets again. Sorry for all those of you that have heard this 100,000 times. In order to be successful at running applications across clouds, you have to be able to create them using an automated process. You cannot rely on using manual steps and bring your app up. The more manual steps you have, the lower your success rate will be. So if you are using an automated process to run an application from a container image, then all of what I've told you today will be possible. You cannot love your app. You need to be willing to kill your app at any time and recreate it using your automated process. That doesn't mean you need to be willing to blow away your data, but remember I told you to put your data in a container, right? Okay, so as long as you're not putting your data in a container, you shouldn't have any love for your containers at all, because you can just rerun the program stuff. All right. Centralized log scheme is an important detail that frequently gets glossed over when people talk about paddle. One of the things that you absolutely do want is the log from the app while it was running. Make sure that you set up that app when you first create the container. You set up that app so that it uses a network logging solution. There are lots to choose from. The ones that are popular today, the most popular one today is Craft. But Greylog and Logstash are equally useful for this purpose.
You have the, and those are just the apps just to throw the thing in. What database it is?
Yeah, if you're using Kibana, chances are that's on Elasticsearch
Yeah.
cluster, Greylog, Elasticsearch, Logstash. You can put it in whatever storage you want, but you need to have a centralized logging solution, whether you're using a hosted service, whether you're using your own. But in order to have a true immutable infrastructure environment,
Yeah.
and to treat things as cattle so that you can literally just blow them away anytime, you need to persist the log output somewhere so that you can
Off the system.
You can do all the quality research and access tracking and all that sort of thing. Okay, so immutable infrastructure. Why is this so important? Why do people keep talking about immutable infrastructure? Now, I had a talk at the last talk for LA about immutable infrastructure. And I really drive to the point that having the same binary artifact that you use when you build your application for test, once it passes test, using that same binary artifact again to deploy your production is critical. So the same runtime libraries are available, the same exact environment that you tested is what goes into production. That is extremely hard to do. Even people who are very disciplined at running Puppet or Chef in a configuration management scenario, it is extremely hard to prevent drift from your development environments and your production environments for good reasons. Developers are innovating; they're doing things to make the application better, and they're not intentionally not changing production because they want production to be stable. So there's always this irresistible temptation to allow dev to drift from production. So there's always this risk that the things that you changed in dev might not be exactly changed the same way in production, so that when you actually do a deploy of that app, it doesn't behave the way you expect. Containerization is a tool that helps you solve this problem. It allows you to create that container image, run that in test environment, use a technique called environment variable injection. So at the time you start that container, you can set environment variables for things like where's my database, where's my username, where's my password, that kind of stuff. That doesn't matter. But keep all of the other things set that do matter, like what version of the SSL library am I running? What is my dependency chain for the plums that are installed on this app right now? So on and so forth. So having that same artifact to deploy in production is the key motivation to doing containerization of images and using immutable infrastructure. Anybody wanting to do continuous integration or continuous deployment needs to value this in order to be successful. Okay. I'm sure I said 25 things that I'm curious about. Take your questions.
You just made me totally impressed. I work in an environment where incremental drift is done every week, and nobody anywhere on the surface of the earth knows how to build production. At this point, we just close production and apply patches and then build.
Yeah, that's very
And
helpful.
it's very good to see this kind of thing. It's not a question. It's just
So, all right. So everybody, is starting to kind of converge on what the best practice is. The truth is, none of us are actually there yet. We've got a clear vision of where we want to be, but or maybe some of us are more depressed than others about how much work it's going to take in order to get there. But at least maybe I've painted the path of how you get from here to there, what tools you could potentially employ in order to get to that point. But you need to have a system by which you can build your application using automation to create the environment that it runs in using automation. And once you've done that, containerize. Your build process needs to produce the container image, and you match that up with the data necessary to run the app. That's another complexity that's really hard to get right. Production application data is never the same. as test application data. And if it is, you're spending a lot of time waiting for synchronization of this stuff. In order to iterate fast and do agile development, by definition, you have to have different data. You have to have less of it in order to iterate that quickly. So that's always a sticking point, where even if you have the same binary artifact that you're deploying, you can still end up with drift problems that are related to versioning of the data, objects that are in the data. But yeah, so look into Docker and Docker images. Use Docker files. That could be your first step to getting that automated process. Now, you could also use other tools for this. You've had Puppet for a long time. You've had Chef for a long time. It's possible to do all of this stuff and never use Docker at all. You can create namespaces using LXC. You can create C groups. You can do all this stuff. But if you want direct access to that, it's there.
Chef, the company, and or Puppet Labs, they're not going down those paths, like making C group resources and tying all that, or recipes.
No, don't
and
make
tying
Docker resources.
Right. So you're saying you just layer your layer Chef or your favorite configuration management tool on top of Docker.
Yeah. So some people think that you shouldn't do configuration management if you're doing cattle. I disagree with that. Okay. Strictly speaking, in an ideal world, you might not need configuration management. If you've automated everything into the build of the container, then you don't need to manage it after it's running, because your only two operations that you ever do on a running app are create and destroy. There's no manage, there's no debug, there's no any of that, right? There's only create and destroy. And if that's the truth, and you have a way to easily create more, then you don't need manage in place. And so the reliance on something like a Puppet is reduced. Now, in practice, people have invested a whole lot of energy into automating using these existing tools. And they're not about to redo all of that work if they can just leverage what they've already done. So you actually see happen in real life is people have a little bit that's done in the Docker container, right? And a little bit that's also done in another orchestration tool or configuration management. Well, those things are used in combination.
You see people using Salt or CFN or whatever to actually create the Docker containers, to create the images, and then after that, deployment requires no more configuration management. You have some kind of a structure besides it. Or something.
No, I haven't seen that. That doesn't mean it's not happening. What I see normally is people have a Jenkins box they use for their continuous integration process. That's the thing that has a script that builds the Docker. Or they use
some sort of git commit, hits
a commit hook
Jenkins.
fires. A commit hook fires. It stimulates the CI system. The CI system does an auto build and bumps out a container image. Then your CD process or your manual deployment process then picks up that image that you created when you kicked off the build and deploys it. Right. The situation you're talking about works for. I talked about two categories of applications: ones that are built for cloud and ones that are not. Right. The ones that are not are going to be containerized less frequently. So you might actually use a Chef recipe or something in order to create a container for that and deploy it a whole bunch of times using the same one. Whereas if you're in the business of developing software, you're going to have a CI system. They're going to be building things all the time.
Do people run the configuration management, can they even run the configuration management systems within the container itself?
Yes.
Okay.
You can run anything you like.
So it's because you're talking about the immutable infrastructure, but from within the system, or within the running instance, it could be changed.
You can. That wouldn't be pure immutable infrastructure. That would be a hybrid.
Okay.
But sure, you can do that. So any process that you can start on a Unix box, a Linux box, I should say, you can put in a container of some kind.
Yeah, because that would be one way to solve the bash 0-day problem. It's like, oh, well, no worries. Puppet says bash require latest, and the repo's up, got the fix. Right. Cool.
Yeah. Am I offending your sense of aesthetics or purity if I just don't want to put my database in a container at all, at least my master? Like, I don't want to try tuning a database by doing immutable iterations of that database. Like, really, I kind of want my database, at least my master, off on the side.
Sure.
There's no one's feelings are hurt, right?
I wouldn't put my database in.
However, if you're trying to deploy that into a test environment, you don't have an automated process to create it that's the same that matches to your production environment, you take on some risk of drift. Because your deployment environment, by definition, came from different roots than your test. So as long as you have a way to create the equivalent of it in test, then sure. Yeah. You just wouldn't put the database in the scope of the orchestration for the app. You would just simply say, here's how you act. Here's the place where you're going to pick up your access information from. Right. Getting to that host.
How does like sysctl.com, big tables, things like that are really kernel related?
Yeah.
How does Docker handle that? If you have a running Linux system which doesn't have big pages, huge pages, I guess is the word. You want to put a container on there that emulates a database environment or big pages. Can Docker do that?
Ask the question a different way. Maybe I'll say something first and then I'll come back to your question to be sure that I've understood it. Okay. Virtualization is about creating an emulated hardware layer. So you're virtualizing, you're making a software-based machine on which you run an operating system. Containerization, there is one kernel on the host, and processes are created on that kernel only. There is no second kernel. So you have the two facilities I talked about, the C groups and the namespaces, in order to constrict how much of the system you can view and consume and account for. Those things are happening within one kernel. So if you've enabled, say, sysctl.com, if you've enabled some kernel feature, that feature will be available to every process that gets started on that kernel, regardless if it's inside a container or not.
But you could put some files into the etc. file system, but they simply wouldn't have any effect because the container is basically. Anyway, I'll do.
Well, or is the file system namespace virtualized as well? So is the /etc you're looking at in the container, this container, let's see, but
using Docker.
Yeah.
So if you speak containers, the answer is inits depends answer.
Okay.
If you're using Docker, by default, what you're going to get is a file system that looks like a complete host with its own OS on it.
Yeah.
In fact, I can run different OSs on the same kernel. So I can run Debian and Ubuntu and Red Hat all concurrently on the same kernel at the same time, each running processes at the same time with different environments, right? In that case, yes, they all have their own Etsy directory, they all have their own, whatever the namespaces allow them to view. It's also possible to create namespaces that overlap on the same file system. So I can create two containers or multiple containers that all have the same view to the same set of files on the same file system. In that case,
like Etsy Shadow or something.
Well,
and password.
Let's say I don't create. So think, everyone knows how CH root works. You have a new root, and you can put things in that new root to produce the illusion that you have your own, right? Okay, so if you say don't CH root this container, leave the root as /, you're creating namespaces around things, but you're just not creating a new file system. In that case, Docker wouldn't be the right tool for this because you wouldn't have any container image. You would be passing in a null container image. You'd say just create a namespace that is the entire host. But you might want to do that for a good reason because you want the IPC namespace, or you want the network namespace, or you want the other restrictions. So you can actually do the very complicated combinations of these things, which is why I mentioned if you want to use containers, you don't necessarily have to use Docker. Docker is kind of a great general use tool, but if you want to do something exotic, you can actually go directly to the low-level feature within Linux. Cool. But by default, yes, you're going to have separate Etsy. So if you want applications who are checking things in Etsy to behave a certain way, then when you build a container image, you're going to want to make sure that you configured all that in the same way that the host is expecting it to behave.
Kevin's question led into my question. Can you talk about the efficiency of, I guess, C groups or all this namespace, the single kernel thing, versus the more traditional virtualization things we've been looking at like Zen or VMware or KVM.
Right. So when you are using, I'm going to refer to it as traditional virtualization, the type that a Zen server or a KVM is going to give you, you're virtualizing the host. And if you create sub-virtualization, you've got multiple layers of emulating hardware in there. There is always an overhead of any restriction. Okay, so whether you're emulating hardware, that's one relatively expensive mechanism of abstracting something. We have hardware support that makes virtualization work very, very fast. It's very close to native speeds, but there is an overhead to it because you are emulating hardware. When you create containers, the things you're doing less work. So there is less code execution that actually happens when your code runs in your app. By the time it gets all the way down to the hardware and executes in the CPU, there are less things happening. There's less distance between your code and the hardware. And in that case, the overhead is lower. And it's order of magnitude lower in the case that you're not emulating hardware for most apps. Now, depending on what your app is doing, you might actually not be able to tell the difference between running my app in a Zen virtual machine and running my app in a container. But if it happens to be doing a lot of file I/O, or it tends to be doing something that does actually have a lot of overhead in it, depending on the frequency of calls, how frequently you get cache hits in the CPU, there's all kinds of like variables here, but those tend to run a whole lot better in containers than they run in virtualization. And then there's the concept of having containers within containers. I didn't talk about this, but who wants to do virtualization inside virtualization inside of virtualization? Nobody actually does that. Why? Because you have 50% of your performance has gone out the window by doing that. But you might have a good reason. Security maybe is a good reason to do that because you're isolating certain things. And maybe you can isolate those same things using a container technique. So you might say, okay, I have a host, I have virtualization inside of that, and I have containers inside of that. That's not going to be nearly as impactful to your performance as post-virtualization. And let's say I want to do host, virtualization, container, and container within container. That's still going to be very similar in terms of performance. For typical workloads, it's going to be very similar in performance to just running the thing in the virtual machine. Or I have my host with container and container inside of that for performance, depending on what it's doing, how many processes it creates, how frequently it creates the processes, how much it interacts with reconfiguration of the network, those sort of operations. Assuming it's not doing that stuff very frequently, the performance will be very, very similar to native. So let me quantify that. It's in terms of fractions of percent. Whereas a typical virtualization workload is going to take anywhere from 1 to 5% of your performance. Virtualization is going to take fractions of a percent.
Yeah, because I mean the rule I heard way back when, at UUASC we've been hosting Unix virtualization talks since like 2009. And I just remember kind of rule of thumb back then. Now this is as the VT calls, and I forgot what the virtualization calls and the chips were just starting to roll out. Right? I was under the impression that your cost for maybe VMware or maybe Zen was anywhere from 10% to 20%, something like that.
For an app that does a lot of I/O, that's true.
But you're saying a container, a C group, with could bring it down
You're
to.
following my best practices. You're not putting your data in the container.
Right.
So all of the I/O is actually happening on the host. All of your I/O is happening on the host. So you're not paying that performance tax, even if you're nesting multiple containers within the container, because you're bypassing that stuff straight through. You're bypassing all of the I/O virtualization stuff that is so expensive. But if you look at just code execution, right? Run these sequences on the CPU.
Yeah.
That stuff through virtualization and that stuff through containers and that stuff natively will all look very similar because of the way that the hardware acceleration works for virtualization today.
So if you're doing your password cracker or Bitcoin mining,
you're not going to see a whole lot of difference from that kind of thing. But every application is doing a mix of ops, so it's going to be a little bit different depending on what you're doing.
Cool.
Yeah.
Can you discuss challenges or strategies or tools for monitoring of production Docker?
Good question. Like monitoring when the processes stop so that you can automatically restart them.
Yeah, that'd be one of the cases, yes. If
Or
you had
the,
a herds
you're
of
talking
cattle.
about performance trade-offs, like where do you go to find out if you get the like, my app is slow? Where in the set of stuff you start trying to hunt?
I don't have a quick answer for that.
No, but it's like, how much does having things in containers change that
Not-
strategy?
not
Or
a
do you just
lot,
go to the
because-
host and start there?
You go to the host. When you go to the host, okay, you've got the superset of all namespaces, right? You've got the root namespace, all of them are derived. So if I run PS on the host, I will see every process that is running in every single container that is started on that. And I will be able to see what container they belong to. And so I would use all the same techniques that I would use for performance debugging an application outside the container. I would just do it on the host.
But you can see that this process belongs to a particular container.
Yes. In fact, you can say what PID is the root PID for this
Okay,
for
so
this
just follow
container
the chain
name.
and that container will be the root for that.
Exactly. I'll talk about this. Are you coming on October 15th?
No.
Well,
I
there's
post
ways that
something
you
on
can actually enter a container and start a shell within the already running container without like SSHing into it. You can just spawn a new process within an existing namespace using a utility called NSCenter. So let's say I'm having trouble with something, this is not working quite right, and I really want to do cattle, but it's not practical right now. I need to actually get into that host and do diagnostics from the perspective of that running application. I can create a shell inside of that namespace, enter it, and now I'm running the same perspective of that app. And I can start, interact with this, you can start to fool around with the network, you can start to figure out what's going on with that. I did that today. I had a host that like spontaneously stopped resolving host names. Didn't know why. Went in, I NSEntered, verified, yes, this container can't resolve host names. I don't know why. I called like I have network connectivity and everything, but like the resolve library wasn't working with the container. It didn't have very why. So I'm like, okay, kill all that container, start it again from the container on it, it started back up and worked after it started. Don't know why. That's what happens. It happens in my Linux box.
It's like cattle. I don't know what.
Yeah.
It's clearly sick. Shoot it.
Exactly.
So one other bit on the monitoring, if you're looking for application performance, say HTTP performance or something, right? If you're doing your external logging, setting your HTTP errors and access stuff off to this external system, you could maybe look at performance or catch certain issues, the number of pages being hit or page sizes, right? You can look at that through your external performance monitoring
all the
system.
techniques that you use to monitor performance and availability of applications today, you can still use if you containerize. It doesn't change. So anything that you would run on the host as an agent to monitor things, you can still use. But what might change is the command you run to restart something. So if I've got an automated, like a monitor that says, okay, if this, then that might be Docker run something instead of user Apache, whatever, right?
I got one more question. So when you're using Docker and deploying these containers, the platform that you're deploying them onto, does it tend to be just bare metal Linux servers, not a whole bunch of virtualized Linux things running on Blade, but just the blades, just running Linux? So you have 5 blades, you have 5 kernels, and you put the Docker images, scatter them around, they're all the same.
It depends. If I'm running on a public cloud, I'm either using the on-metal product from Backspace, where I've got the entire host, in which case I'm putting them on the metal, or I'm using the performance flavors within the Backspace cloud, in which case I'm starting up virtual machines and creating containers in virtual machines. It really depends what the performance characteristics are and what my budget is for running that application. If it's something small that doesn't need a whole lot of performance resources behind it, I might just start with a small VM and create a container inside of that, or create a couple of containers inside of a relatively small code. But if it's an extremely demanding application, I would create the bare metal instance and I would deploy my containers directly on that. So that the host itself would be running CoreOS, which allows me to run Docker containers on it. And then I would just say Docker run this container. First I would do a poll, and then I would say Docker run against that container. And
And the, not so much cloud, but
in a private environment, assuming you don't have hostile workloads and you're doing multi-tenancy against each other, then skip the virtualization entirely and just run containers straight up. That's going to give you the best oversubscription rate. That's going to give you the best performance characteristics and more simplicity. Complexity means less things breaking software, right? But if you're running, say, the reason why you're using containerization is because if you're trying to consolidate your infrastructure on less hardware, because say hardware ops is really expensive for you, so you want to have as few pieces of physical equipment as possible. In that case, you might actually want to mix virtualization technology and containers together in order to get the right isolation between potentially hostile workloads. Virtualization is still the right tool if you need a security barrier between different running apps. Although namespaces are convenient, they're not impervious to kernel bugs. So if I do have a kernel bug and I can escape up into the root namespace, I now have access to all containers. Remember I told you to start an arbitrary process in a namespace? Well, once I get root on the host, then I can access everything on the host.
it didn't sound like there's any fairness of file IO in this container.
Sure there is. That's what the secret is. It's one of the things that's secret. Yes, sir.
Is there anything that controls or helps you alleviate issues where the SQL container is oversaturating the server? You got a weak server, then it'll actually move to a higher end server. Anything going on in that realm?
So there is a thing called CIRU, which allows you to snapshot memory state of your app, persist it, and then start it up on another host at another time. CIRU is not currently integrated with Docker because it doesn't work with all types of workloads and all types of resources that you might have created in the app. If all you do is have standard in, standard out, and a bunch of malloc memory segments, then CIRU is going to work. But if you have crazy stuff like semaphore, shared memory segments, all kinds of that kind of stuff, that's not going to snapshot cleanly and move to another host. So in a general case, that doesn't work in terms of like live migrating a workload from one host to another. Not yet, at least. But there are some projects that are attempting to do that. What you can do, though, is you can say, stop that process, persist the contents of the container, and push it to the repo, to the image repo, and then do a pull on another host and start elsewhere. You can even do the commit, push, pull while the process is still running, kill it off and start it elsewhere. And say you got maybe load balancer in front that allows you to move things around, or you've got an arbitrary you use in order to relocate the address. Yeah. But that's very commonly done. I mean, I do that all the time with my production stuff, where I want to move busy workload from one host to another. I just use the container and just a mechanism to move the environment that the app runs in, and then I hold the state elsewhere. So I either have a 12-factor app where all my state is in the database, or I have a bind mount where all my things are on a network block storage system. So I'm just going to mount that volume on the target host before I start the application. Sweet.
There we go. I guess so. Hey, why don't you tell us? So you're going to be doing this presentation at the OpenStack Summit?
This plus a demo of what the next generation of LibSwarm looks like.
Cool.
At Paris. But I didn't think it would be fair to this group to show you what it all looks like now when it's all going to be different. Because you already have like a more twisted view of how things actually look. Because the user experience is going to be much more simplified.
And I guess, did you have any comments about Docker integration with OpenStack specifically?
Yeah, so
you hinted at, hey, how there's certain components like Nova or whatever deal with Docker. But,
yeah, so I said today you can use containers on OpenStack if you use the LXC driver,
okay.
An LXC root driver, which is using LXC and lib, shoot, I can't remember the name of the thing right now. Libvirt. Okay, so libvirt and LXC in order to produce namespaces and secrets. Or you can use the Nova Docker driver. And if you do that, you have the ability to create and destroy containers, but you don't have access to the advanced features that are unique to running containers versus running virtual machines. Because Nova was designed for virtual machines and bare metal and creating hosts. It wasn't intended to control processes running on those hosts and setting environment variables and binaries and all this stuff that has nothing to do with the host. It has to do with the context that a process is going to be started in. So the new project for OpenStack called Magnum is designed to give that overlay of those additional features that are specific to containers along with them. So how Magnum works is you get a new API that allows you to have the ability to do all the container stuff very similar to what the Docker API has in it, plus multi-tenancy, plus asynchronous operation. And it will create on the back end Nova instances, whether they be bare metal, virtual machines, or containers to put your containers into. Now remember I said when you nest containers, you don't take a performance penalty, or if you do, it's a small performance penalty, an order of magnitude smaller than virtualization would be. So if what you really want is optimal performance and you want the full features of containers, you would use Magnum in combination with Nova. So you would talk to one API and you would say, give me container, and it would create running Nova instance with container on it. The next one I create, I'm going to get another placement depending on how many of these things I have, right? I might be round robining around them. I might be stacking them on sequentially. I might have different strategies for scheduling the creation of that subcontainer. But I'm going to get bare metal speeds, and I'm going to get really fast start times.
Cool.
So create a container takes sub-second on a single host. Going through a network API, reasonable expectation is a few seconds in order to start one. Whereas starting a virtual machine, you have to go through the entire boot sequence, which takes a minimum of 12 seconds, and a typical start of a kernel is going to take you around a minute until you actually have running processes that are responsive on the network. So a minute is about as fast as you're going to get a virtual machine, whereas if you're starting containers, you can rely on those happening in just a second. Because you're not doing as much work. You're skipping all the hard part and you're getting right to just start a process. Right? It just happens that the context that process starts in is more complex than what we think of now when we run a command on the shop.
And if you're already in the cattle mindset, this is awesome because you can just spin up more cows.
Right. If you're in love with Mesos or something, we put Mesos, you integrate Mesos with Magnum. Magnum is now integrated with Nova. Nova is integrated with your hardware, right? And so now I've got this high-level abstraction that allows me to
I think you just killed somebody. Okay. Hey, thank you very much. Did you have anything else you wanted to mention, Adrian? Y'all hiring at Rackspace?
Yeah, we're hiring. Especially if you love San Antonio. Yeah, I think we've got like 1,000 jobs.
Hey.
Yeah.
Well, hey, thank you for speaking at UUASC again. And you're presenting, what was the date?
October 15th.
That's like next week-ish?
Yeah, next Wednesday. It's right after the cloud engineering meetup. So
That's right.
Tuesday is the 14th. Wednesday is 15th.
And so what are you going to present?
That's the Docker in production quirks and tips for running Docker and all of its various limitations.
Well, yeah, but hey, thank you very much, and hopefully we'll have you back here in a few to talk about something different, but perhaps similar. So thank you very much. Also, thank you to Carolyn and the folks at Q. And by the way, we're going to head over to Islands and have some food and drink. You're welcome to join us there. Also, next month, John, I'm sorry for your last name. I'm talking about, what was it? Mitchell. John Mitchell will be talking about improvements to networking in the Linux kernel, which will help your virtualization go even faster. So hit the Meetup site for that, and always make sure you go to UUAC.org and that you're on our mailing list. Thanks, everybody.
I'll be the